Let's run through an example of how we can find where a function is increasing or decreasing based on using the first derivative test. So here we have our first example, x squared minus 4 to the 2/3. So the first thing we're going to need to do is find the derivative and then analyze the derivative. So let's find the derivative. So f prime of x equals 2/3 x squared minus 4 to the negative 1/3. And then let's observe the chain rule here. We have a differentiable function on the inside here, so multiply that by 2x. Now, next thing we're going to need to do is find critical values, where the derivative is 0, where it's undefined. That's not really easy to do here. It's not really user-friendly. So let's make it a little bit more user-friendly. So I'm going to rewrite this. 2/3 times 2x is 4/3 x. But I'm going to write that a little different. So I'm going to write the 4x up top. 2 times 2 is 4x, right? Leave the 3 on the bottom. And I'm going to rewrite that 1/3 power as a cube root, right? So the cube root of x squared minus 4. Okay, so now, like I said, where we want to go with this is we want to find critical values. Where's the derivative 0? Well, that would happen right here, wherever 4x is equal to 0. Or, of course, where's the derivative undefined? So where is the denominator equal to 0? And so where's really x squared minus 4 equal to 0? That's really where we need to focus our energy, right? Well, if we do this, we have two critical values, right? 3, actually. Critical value at x equals 0, that comes from the numerator, right? And then critical values at plus or minus 2, that comes from the denominator, right, where the derivative is undefined. So step 1, find the derivative. Step 2, find critical values. Step 3, analyze the derivative based on those critical values. And the way we're going to do that is we're going to use a number line. So I'm going to draw a number line here, and I'm going to place my critical values on that number line. -2, 0, 2. You'll notice we have 4 distinct intervals here that we need to test. Now, it's not always 4 intervals, but it is in this problem. How do we do that? Well, we need to pick numbers in the interval, any number, and then substitute that number into the derivative to see if the derivative is positive or negative. Why? Well, when the derivative is positive, the function must be increasing. When the derivative is negative, the function must be decreasing. So let's do that. Start with, let's say 10, right? So I'll call it a TV, a test value, right? If we use 10 as a test value, you could use 3, use 2.5, anything bigger than 2. When we put 10 back up in here, we get a positive up top and a positive on the bottom, right? So overall positive, that means f must be increasing right there. Okay, so now let's look at what happens in between 0 and 2. So let's say our test value is 1, right? All right, again, substitute 1 back into the derivative. We're always back in the derivative. So top is positive again, but this time 1 squared minus 4, that would be a negative, and the cube root of a negative is a negative, right? So overall here, the derivative is negative. That means the function must be going down, right? Okay, let's take a look at maybe -1 here in this next interval. Now the numerator would become negative, but so would the denominator. -1 squared, 1, minus 4, negative, cube root, still negative, right? And so negative over a negative is a positive. So therefore the function is increasing. And then finally, right, if we pick another test value way to the left of -2, let's say -10 this time. Again, I'll get a negative on the top, but on the bottom, -10 squared, 100. 100 minus 4 positive, cube root of that positive, right? So overall derivative negative, the function is decreasing. So that takes care of really all the grunt work, right? And so now that we know that, we have to just draw our conclusion, right? So what can we say? Well, 2 things. First and foremost, we know that f is increasing in 2 intervals here, right? So f is increasing, I'll just abbreviate that, on -2 to 0, right? And then again, from 2 to infinity. And f is decreasing, right, from -infinity to -2, and then again from 0 to 2. And then lastly, what do we also know? Well, if the function went from decreasing to increasing, that means it had to have a relative minimum. So at -2, for instance, and at 2. And if the function went from increasing to decreasing, it had to have a relative maximum. So we also want to specify that as well. So we have a relative max at x equals 0, and relative mins at x equals plus or minus 2. So I hope this has been helpful. Thank you for watching.